superheated steam is steam at a temperature higher than its vaporization point at the absolute pressure where the temperature is measured. The steam can therefore cool by some amount, resulting in a lowering of its temperature without changing state from a gas to a mixture of saturated vapor and liquid. If saturated steam is heated at constant pressure, its temperature will also remain constant as the vapor quality increases towards 100% and becomes dry saturated steam. Continued heat input will then superheat the dry saturated steam. This will occur if saturated steam contacts a surface with a higher temperature. Superheated steam and liquid water cannot coexist under thermodynamic equilibrium, as any additional heat simply evaporates more water and the steam will become saturated steam. However, this restriction may be violated temporarily in dynamic situations. To produce superheated steam in a power plant or for processes, the saturated steam drawn from a boiler is passed through a separate heating device which transfers additional heat to the steam by contact or by radiation. Superheated steam is not suitable for sterilization. This is because the superheated steam is dry. Dry steam must reach much higher temperatures and the materials exposed for a longer time period to have the same effectiveness or equal FO kill value. Superheated steam is also not useful for heating. Saturated steam has a much higher useful heat content. Slightly superheated steam may be used for antimicrobial disinfection of biofilms on hard surfaces. Superheated steam, a unregistered trademark's greatest value lies in its tremendous internal energy that can be used for kinetic reaction through mechanical expansion against turbine blades and reciprocating pistons, that produces rotary motion of a shaft. The value of superheated steam in these applications is its ability to release tremendous quantities of internal energy yet remain above the condensation temperature of water vapor. At the pressures at which reaction turbines and reciprocating piston engines operate. Of prime importance in these applications is the fact that water vapor containing entrained liquid droplets is generally incompressible at those pressures. If steam doing work in a reciprocating engine or turbine cools to a temperature at which liquid droplets form, the water droplets entrained in the fluid flow will strike the mechanical parts of engines or turbines, with enough force to bend, crack or fracture them. Superheating and pressure reduction through expansion ensures that the steam flow remains as a compressible gas throughout its passage through a turbine or an engine, preventing damage of the internal moving parts. Saturated steam is, in contrast to superheated, steam that is in equilibrium with heated water at the same pressure, that is, it has not been heated past the boiling point for that pressure. If saturated steam is reduced in temperature, it will condense to produce water droplets, even if it is still considerably above the boiling point of 100 degrees Celsius at standard pressure. These condensation droplets are a cause of damage to steam turbine blades, the reason why such turbines rely on a supply of dry, superheated steam. Dry steam is saturated steam that has been very slightly superheated. This is not sufficient to change its energy appreciably, but is a sufficient rise in temperature to avoid condensation problems, given the average loss in temperature across the steam supply circuit. Towards the end of the 19th century, when superheating was still a less than certain technology, such steam drying gave the condensation-avoiding benefits of superheating without requiring the sophisticated boiler or lubrication techniques of full superheating. Uses Steam engine Superheated steam was widely used in mainline steam locomotives. Saturated steam has three main disadvantages in a steam engine: it contains small droplets of water which have to be periodically drained from the cylinders. Being precisely at the boiling point of water for the boiler pressure in use, it inevitably condenses to some extent in the steam pipes and cylinders outside the boiler, causing a disproportionate loss of steam volume as it does so. And it places a heavy demand on the boiler because a large amount of water has to be evaporated per unit volume of steam. Superheating the steam dries it effectively, raises its temperature to a point where condensation is much less likely and increases its volume significantly. Added together, these factors increase the power and economy of the locomotive. The main disadvantages are the added complexity and cost of the superheater tubing and the adverse effect that the dry steam has on lubrication of moving components such as the steam valves. Shunting locomotives did not generally use superheating. The normal arrangement involved taking steam after the regulator valve and passing it through long superheater tubes inside specially large fire tubes of the boiler. The superheater tubes had a reverse bend at the firebox end so that the steam had to pass the length of the boiler at least twice, picking up heat as it did so. Processing. Other potential uses of superheated steam include drying, cleaning, layering, reaction engineering, epoxy drying and film use where saturated to highly superheated steam is required at 1 atmospheric pressure or at high pressure. Ideal for steam drying, steam oxidation and chemical processing. Uses are in surface technologies, cleaning technologies, steam drying, catalysis, chemical reaction processing, surface drying technologies, curing technologies, energy systems and nanotechnologies. Superheated steam is not usually used in a heat exchanger due to low heat transfer coefficient. In refining and hydrocarbon industries, superheated steam is mainly used for stripping and cleaning purposes. Pest control. Superheated steam is used for soil steaming. Steam is induced into the soil which causes almost all organic material to deteriorate. Soil steaming is an effective alternative to chemicals in agriculture. See also, superheated water. References